Today we are going to discuss an important topic of the chapter, that is electric dipole. So what we understand by the concept of dipole? So basically, what is a dipole? It is an arrangement of two equal and opposite charges which are separated by some distance. So let us try to understand what is the arrangement of this dipole. So here you can see that there are two equal and opposite charges. One is plus q, another one is minus q, and both the charges are separated by some distance, and this distance is taken as a convention, and it is always taken as twice a, or we can take the distance to be twice l. So either it can be taken as twice l, or we can take this as 2a. So this is by convention. So this is the arrangement of the dipole. So where we have two equal magnitude charges and the signs are opposite, that means one has to be positive and other has to be negative. Now what is the practical example of dipole? So practically we can see the dipole like HCl. So here we have H plus and Cl minus. Again we have NaCl, that is Na plus Cl minus, and also we have H2O, right? So here you can see H is positive and O is negative. So these are the practical dipoles that we have. So what is the meaning of dipole? It is an arrangement where there will be two equal and opposite nature of charges, and both the charges are separated by some distance. So this distance is taken as a convention. It can be taken as twice a, or we can take this as 2l. Now let us try to understand the another concept of dipole, that is known as the dipole moment. So what is the meaning of dipole moment? So dipole we cannot measure physically. So to measure the strength of the dipole, what we do, we define a new quantity, and this new quantity, as you can see, that it is known as the dipole moment. So what is the meaning of dipole moment? So it is defined like this, that it is the product of the magnitude of any one of the charge and the distance between the two charges. So what is the meaning of either charge? Either means it can be plus q or it can be minus q. So we have to take the magnitude of any one of the charge and multiplied by the distance between the two charges. So let us see the expression of dipole moment. So the expression is given like this. It can be taken as q charge multiplied by the distance between the two charges, so that it was twice a. So already you've seen the arrangement of the dipole. One is minus q, one is plus q, and the distance between them was twice a. So how to define the dipole moment? It is defined like this, that it can be taken any one of the charge. The magnitude of the charges are same, so we can take plus q multiplied by the distance. So what is the distance between the two charge? It is given by twice a. Now it is a vector quantity. Why it is a vector quantity? Because the distance that we measure between the two charge, this distance is a vector quantity because it has a direction also, and the direction is always taken in this direction, minus q to plus q. So it will be a displacement vector, and so the dipole moment will be a vector quantity. So if it is asked to give the direction of the dipole moment, so what will be the direction? It will be from minus q charge to plus q charge. This is very important. In many numericals we are going to apply the direction of the dipole moment. So what is the direction of the dipole moment? As you can see in the diagram, it is from minus q charge to plus q charge. Now what can be the SI unit of dipole moment? So that is given by coulomb meter, because you all know that the unit of charge is coulomb and the unit of distance is given by meter. So the SI unit of dipole moment is denoted by coulomb meter. And what is the symbol of dipole moment? It is given by capital P. So I think you've understood the meaning of dipole and what is dipole moment. So let us now try to do some numericals based upon this concept. So the first question, you can see two charges of magnitude 2.5 coulomb and minus 2.5 microcoulomb. So these are placed at a distance 0,0,2 centimeter, and another one is placed at a distance 0,0, minus 2 centimeter respectively. So what it is asked? So in this question it is asked to calculate the dipole moment. So if we draw the diagram, so you can see that this is our x direction, this one is our y direction, and this is the negative z axis, and this one is the positive z axis, right? So this is plus z and this one is minus z. So what we can see that in this question it is given that there are two charge, one is 2.5 microcoulomb and second one is minus 2.5 microcoulomb, and the distances are given. So the distance is given 0 comma 0. You can see the question 2 centimeter, right? So this is 2, and here it is given the coordinates 0 comma 0 minus 2. So it is asked to calculate the dipole moment. So how to find out the dipole moment now? So it is very simple. It is given by charge multiplied by the distance between the two charges. So what is the magnitude of the charge in this question? It is 2.5 microcoulomb. So microcoulomb means it is 10 to the power minus 6. And what is the distance between the two charge? So as you can see, the distance between the two charge, it is given by 2 plus 2, right? So that will be how much? 4 centimeter. So I think it is clear to all of you. So the distance between the two charge is given by 2 plus 2, so that is 4 centimeter. So what we can multiply, this will be 4. So this is the solution of the question. So as you can see, the dipole moment is given by 2.5 microcoulomb multiplied by the distance. So that was how much? 4 centimeter. So like this, we have to solve the question of dipole moment. Sometimes the coordinates will be given and you will be asked to calculate the distance. Now let us move to another question here. You can see the diagram given. There are three charges plus q and at the origin minus 2q. So here it is asked to calculate the net dipole moment. So what is the net dipole moment? How we can find out? So let us try to understand this question. Here you can see that one charge is given plus q, and here is also given plus q, and let us take this one is minus q and minus q, because what is given in the question? It is given that minus 2q. So how we can write minus 2q? It can be minus q, right? So that will give you minus 2q. So that means at the origin there are how many charges? Two charges. One is of minus q and second one is also of minus q. Now we know the direction of the dipole moment. So the direction is given from minus q charge to plus q charge. So let us take the dipole moment P1, and this one let us take the dipole moment to be P2. So I think it is clear to all of you how we have done this question. So we can draw the diagram again. This one is our P1 and this is our P2. Since the charges are of equal magnitude, so we can take the dipole moment to be same only. So if this is P1 and this is P2, then both are vector quantity. So how we can write this one? So if they are vector quantity, that means we can write like this, that this is one vector quantity and this is another vector, right? And the resultant will be given like this. This is a parallelogram, right? So what is the net dipole moment? So the net dipole moment will be given by p square plus p square. So that is given by how much? We can say p root 2. So this is our net dipole moment. So I think it is clear to all of you. So how we can find out this question? So here you can see, since at the origin minus 2q charge is given, so we can write this minus 2q like this, minus q and minus q. So that means there will be two dipole. One dipole moment is given by P1, another dipole moment is given by P2, and the directions are shown in the diagram. Now you can see that all the charges are of same magnitude, so their dipole moment will also be same. So we have taken P1 is equal to P2, and this is equal to how much we have considered P. Clear? So now from that concept we can apply the vector. So by using the vector we can find out the net dipole moment. It is very simple. The answer will come out P times root 2. So I think it is clear to all of you. So let us move to the next topic, calculation of electric field due to the dipole. So our first point will be at the axial point, right? So what is the meaning of axial point? Axial point, as you can see in this picture, that there are dipole minus q and plus q, right? And we have taken the point P. So point P is our axial point, right? This is known as the axial point. So I think it is clear. The Here you can see that there are two charges, minus q and plus q, and both are separated by how much distance? 2 times a. So you can see that the distance between minus q and the point O will be a. Again, from O to plus q, it is given by a. And what is r? We have taken r is the distance between the center of the dipole and the point P. So let us calculate the electric field at the point P due to both the charges minus q and plus q. So here you can see the electric field due to the charge minus q is given by minus kq divided by r plus a whole square. Because you know that electric field expression is given by how much? It is given by kq divided by r square, right? So which point we are finding the electric field? At the point P. So you see the distance between the point P and the charge minus q. So as you can see in the diagram, the distance between the charge minus q and the point P is given by r plus a. So what will be the electric field? It will be written like this: minus kq divided by r plus a whole square. And similarly, the electric field due to the charge plus q will be how much? Kq divided by r minus a whole square. So why it is r minus a? Because you can see that the distance between the charge plus q and the point P, this particular distance, this will be how much? If we measure from the diagram, so then you can find out that this particular distance will be r minus a, because the distance between the point O and the point P is r, and again the distance between the point O and charge plus q is a. So what will be the distance between the charge plus q and the point P? So that will be r minus a. So I think it is clear to all of you. So let us now calculate the net electric field. So net electric field will be how much? It will be simply E minus Q plus EQ. So let us try to calculate the net electric field. So we can write down the equation. So net electric field is given by minus KQ divided by R plus A whole square, plus what? How much we can write? KQ divided by R minus A whole square, right? So from here, which quantity we can take common? So we can take kq common, right? So if we take kq common, so that means it will come out 1 by r minus a whole square, right? Minus how much we can write? 1 by r plus a whole square. I think it is clear to all of you. We have taken kq common, so that will be 1 by r minus a whole square minus 1 by r plus a whole square. So again you can see that this we can further simplify this one. So how much we are going to get? kq, this if we write, so that means this will come out r square minus a square whole square, right? The denominator will come out how much? R square minus a square whole square. And similarly in the numerator, what we can get? R plus a whole square, and this one we can write minus r minus a whole square. Now breaking this term in terms of a plus b whole square and a minus b whole square. So if we break up this one, then how much we are going to get? A plus b whole square. So if we write this one, then r square will get cancelled out, a square will also get cancelled out, and this will be 2 times re, right? Because one will be 2ra, and again this will be 2ra, right? So plus 2re divided by same thing, r square minus a square whole square. This I think all of you have understood. Then how, what we can write this one? kq, this we can write 4, you can see this one 4ra, right? This calculation you can try this by yourself also. This we are going to get r square minus a square whole square. Now from here, can we write like this, that 2q, right, and here we have written 2a multiplied by r. This can we write like this. So what I have done here, 2 in the numerator we have written with charge q, and again we have written another 2 with a. So this will ultimately give you 4ra, and from here you can see one thing, that q multiplied by 2a, so that is how much, p, right, and it is multiplied by r. This is r square minus a square whole square, right. So this will be the net electric field. Now we can take one approximation here. So what will be the approximation? Here we take r is very much greater than a. Then what will be the net electric field? So net electric field will be how much? That means we can neglect a in compared to r. So what will be the denominator then? This will be r to the power 4, and in the numerator already one r is present, so r and r will get cancelled out. So how much we are going to get? So this will come out 2kp divided by r cube, right? So this is the net electric field. So the net electric field will come out how much? 2 times kp divided by r. So this is the net electric field at the axial point. And this expression is very important for your derivation. This will come for 3 marks question in the exam. So how we have done this derivation? We have taken electric field due to minus q charge and plus q charge. Then we have calculated the total electric field, so that will be the sum of both the electric field, and after some simplification we have got the answer to be 4ra divided by r square minus a square whole square. So we have written 4 as 2 multiplied by 2. Then we have applied the concept of dipole moment, so that is q into twice a, right. So what is dipole moment? Here I will write dipole moment is given by q multiplied by 2a, right. This is the dipole moment. So this we have applied here, and by application of this one we have got the total electric field. So this will come out how much? 2 times kp divided by r cube. So this derivation you have to practice, then you will be able to understand. Clear? So now let us move to the next point, so that is at the equatorial point. So first we have done for the axial point, now we are going to do for the equatorial point. So here you can see the point P is at the equator, and there are dipole minus q and plus q separated by some distance twice a. So let the distance from the point P to the point O, let us take the distance to be r. So then this will be how much? This will be under square root r square plus a square, and this will also be same r square plus a square, right. Clear this much? So now let us try to find out the direction of the electric field. So you can see that minus q charge will apply the electric field in this direction, and similarly plus q charge will apply the electric field in this direction, right. So then you can see that we have resolved the electric field into two components. So you can see that the vertical component of both the electric field will get cancelled out because they are opposite in direction. So which component will be left? Only the horizontal component. So here theta is the angle. So here you can see that the net electric field will be how much? So that is given by 2 times E cos theta. And what is E? E is nothing but E1 is equal to E2 is equal to E, right? The magnitude of the electric field will be same. Why this will be same? Because charges are same and distance is also equal. So both the magnitude of the electric fields are equal, and this is taken to be E. So what will be the net electric field? So the net electric field will come from the horizontal component, so that is given by twice E cos of theta. And what about the vertical component? So vertical component, as you can see in the picture, so this will get cancelled out because they are opposite in direction. So only we get the net electric field for the horizontal component. So now we have to calculate cos theta. So as you can see, cos theta is given by base by hypotenuse, so that will be, we can say this is the base, right, and this part is the hypotenuse. So from here you can find out the electric field. So we have put the expression for cos theta, then we have to calculate. So after calculation we'll be getting like this. Here also same approximation, r is very much greater than e. So then what will be the net electric field? So this we can write like this, right? This is charge and this is 2a divided by, so we can neglect which quantity, a, in comparison to r. So how much we are going to get? So this will be r cube in the denominator. So I think it's clear to all of you. This a we can neglect in comparison to r. So finally what will be the expression we are going to get? So finally how much we are going to get now? So therefore e net is how much? So that will come out, you can see here, this is k, this is p, and this one is r. But in the vector form when we write, so there will be one negative sign. So why there is a negative sign? Can anyone answer why there will be a negative sign? Because you can see the diagram here, you see that the dipole moment, what is the direction of dipole moment? This already I have told you earlier, dipole moment is from minus q charge to plus q charge, right? This is the dipole moment. And you see the direction of the net electric field, are they same direction or opposite direction? This is our net electric field, right? So both the direction are opposite. Since they are opposite in direction, so we have taken the negative sign. So I think it is clear to all of you why there is a negative sign. Negative sign represent e vector is opposite, right? Opposite to p vector. I think this much is clear to all of you. You can see from the diagram that the net dipole moment is opposite to that of electric field. So these two derivation we have completed. So let us move to the next topic. So next topic is our dipole placed in uniform electric field. So now we are going to place the dipole in the uniform electric field. This is also a very important concept. So what is the meaning of uniform electric field? How we denote the uniform electric field? So uniform electric field is denoted by the parallel lines. This you have to remember that always when we denote the uniform electric field, it is denoted like this. Parallel lines, we have to show the uniform electric field. Now there is one dipole present. Say this is the dipole minus q and this one is plus q. So what will happen? This dipole will experience force. So because of the electric field, so one force will be like this, that is denoted by QE, and another force will be in the opposite direction, so that is denoted by minus QE, right? So now you can see that both the forces are equal and opposite. So what will happen? This dipole will, we can say that this dipole will experience a torque, right? This dipole will experience a torque. Why there will be torque? Because the forces are equal and opposite in direction. But what about the translational force? Is the dipole going to experience any translational force? So obviously the answer will be no. Why? Because you can see in the diagram that the net translational force will be how much? So that is plus QE and minus QE. So what will be the net translational force? So that will be 0. So what we can say, that when the dipole is placed in the uniform electric field, then the dipole will not experience any translational force, but it will experience a torque. So why it will experience the torque? Because the dipole will experience equal and opposite force due to the electric field, as you can see in the diagram. So this will experience a torque, right? So how to find out the torque? So here we are again taking the electric field lines like this, uniform electric field, and say suppose this is the dipole and this is making some angle theta, right? This is minus q and this one is plus q, and this distance is how much? 2a, and let the perpendicular distance we have taken this one. So let us denote the perpendicular distance to be A and B. So what is AB? AB is the perpendicular distance from line of action of force, right? Line of action of force. So as you can see in the diagram that the line of action of force will be like this, right? This is the line of action of the force, and AB, as you can see in the diagram, this is the perpendicular distance from the line of action of the force. So now how to find out the torque then? So that expression of torque is given like this. It is the, we can say the force, right? Force multiplied by the perpendicular distance. This you've got in class 11 also. Then we can write the force as q into e. And what about the perpendicular distance? So this distance we can calculate from the geometry. This is a right angle triangle, and by using the geometry you'll get twice a sine of theta. This you have to do by yourself, and you can verify the answer, because you see that in the diagram the triangle is a right angle triangle, and by using sine theta you will get the answer of AB. So AB will be how much? This will come out twice a sine of theta. This you can check yourself and verify the answer. So AB will come out twice a sine of theta. So we can write this one now. So Q into E multiplied by how much? Twice A sine theta. Then what will be the expression of torque? So this we can write together, and this is E sine of theta. Again, what is Q into twice A? Q into twice A, as you all know that it is denoted by P, dipole moment, then it is E, and then it will be sine of theta. So this is a vector quantity, so we can write tau vector is equal to P vector cross what we can write? E vector, right? So this is the torque. So this much is the torque that is experienced by the dipole when it is placed in the uniform electric field. Clear? I think you have understood this much. And calculation of potential energy of the dipole, this we'll do in the next chapter. So only in this chapter we are going to learn about the torque experienced by the dipole. So now we have seen that dipole will experience a net torque when it is placed in the uniform electric field. But what about non-uniform electric field? Say there is a non-uniform electric field is present. Then what will happen? So only we have to remember one sentence, that in the non-uniform electric field, the will experience dipole will experience a net force a net force along with torque, right? It will experience a net force along with the torque. So although it will experience torque, but it will also experience a net force, and the direction of this net force will be along the direction of the net electric field. Clear? So non-uniform electric field means the electric field is not constant everywhere. So sometimes it will be greater and sometimes it will be smaller. So the dipole will not only experience the torque, but it will also experience a net translational force, and that will be in the direction of the increased electric field. Clear? So I think up to this much it is clear to all of you. Thank you all of you.